So we're going to look closely at natural radioactivity here for a little bit with this lesson. Radioactivity, if you remember, is the spontaneous emission of particles from your nucleus. So let's talk through some of those particles that get emitted. There are, just a handful of types of radiation that will come off of a substance, a unstable nucleus. One is an alpha particle. Now let's go to the light board and let's review what all of these particles look like in terms of writing their nuclear charge and their mass number. So in an alpha particle, we have got our helium nucleus, and so there are 2 protons and 2 neutrons giving a mass number of 4. It would be equally okay to call this a particle that looks like this. So those are 2 ways of writing your alpha particle. The next one would be your beta particle. Now your beta particle is coming out of the nucleus, but it is nothing more than an electron. So we can write it as an electron, which would have a -1 as its charge, and it would have no mass, because remember that top number is the number of protons plus neutrons, and an electron doesn't have any of that. Now, if this is a beta particle, it would be equally correct to write it with a beta when you're doing nuclear reactions. The next particle is our gamma particle, which is really a gamma ray because it doesn't have any mass at all. So we would use the gamma symbol. It has no charge, it has no mass. So there's no other way to write the gamma particle. The next one is a positron, and a positron is a positively charged electron. So we go back up to this symbolism, but what we would have, instead of a -1 down there, we would have a +1 down there for its charge, and again, it has no mass, and it would be equally correct to use a beta, because we used a beta up here, but have the +1 and the 0 for that. And then one last one would be electron capture. Now all of these up to this point are what the nucleus is giving off in the radioactivity. It could capture an electron, and that would just be the same symbol as an electron right here, but it would be on a different side of the equation. It would be a reactant rather than a product. So those are your common types of emissions or captures when you have spontaneous natural radioactivity. We're going to examine what is called a radioactive decay series that's defined right there. And it is a special way of showing how you can take a nucleus that is unstable and what kind of path it will take before it finally reaches stability. Now we're going to look at one here, okay? This is the uranium decay series. And in the uranium decay series, you're starting with uranium-238. You see that up there at the very top. And it is telling you what is decaying. So in this case, it starts with uranium-238, and an alpha particle, a helium nucleus, is leaving, and it takes a certain amount of time for that to happen. So you will see a half-life written there, and what it turns into after that alpha particle has decayed. So when we look at this decay series, we ought to be able to translate this into our nuclear reactions that we're used to writing. So we're going to examine this one first. When we examine this one, what does it mean? Well, it means that we are going to start with uranium-238, okay? And down here below is 92. That is its atomic number. It is undergoing a decay and turning into thorium, and there's a 90 as its atomic number that's associated with it on the periodic table, and the top number is 234. The other thing I am writing is either this or this, either one is fine. It shows it as an alpha particle being emitted. When we're writing a nuclear reaction, we include the 2, we include the 4, and we remember that these numbers have to add up to the same as these numbers. these values on the top have to add up to these on the top as well. So that is a nicely balanced nuclear reaction showing that first decay in its decay series. Let's just practice one more here. If you go a little bit further down, we have PA 91 as the bottom number and 234 as the top number, okay? We see that it is turning into uranium, and the number up here is 234. Okay, the bottom number changed, the top number did not change, because what happened here? We see that a beta particle was emitted. What is a beta particle? It is an electron, okay? So if you add these two numbers together, you get 91. If you add these two numbers together, it is 234. So you should be able to take any one of those decays mentioned there, and you should be able to turn it into a balanced nuclear reaction. Now, I have not shown the entire uranium decay series, but in a decay series, it'll start with the unstable isotope, and it doesn't typically become stable in one nuclear reaction, in one radioactivity emission. It has a series of this until it finally ends up as a stable nucleus. And we see here that lead-206 is a stable nucleus, and that is the highest atomic number that can have a stable nucleus. So we have a decay series that we have seen mentioned here, translating into chemical or nuclear reactions along the way.